will learn about limit of a function in this section. The limit of a function is defined as limit of f of x when x is approaching a equal to L. And we say that the limit of a function f of x as x approaches a equals L. This is how we read this limit definition in the box. If we can make the values of f of x arbitrarily close to L, as close to L as we like, by taking x to be sufficiently close to a on either side of a but not equal to a. So let's try to understand this using a function which is a parabolic function x square negative x plus 2. We have been given a graph of this function here for x near to, and when we see the graph, we see we have values of graph when x is approaching 2 from the left, and we also have values of the graph when x is approaching 2 from the right. And all these values have also been tabulated here in the form of a table. So let's try to read this table carefully. Now, you see that the starting value of x is 1. You plug in 1 in the function, calculate the functional value, you get 2. Similarly, plug in 1.5, calculate the functional value. So as we see the x values here, the x values are increasing starting from 1 all the way up to 2. So you're moving from 1 to 2 in this direction. And you call this as limit x approaching 2. You're moving towards 2 from the left. So you put a minus sign. This minus is nothing to do with the subtraction minus, but it is something to do with the direction of a limit. You're approaching 2 from the left. So hence limit x approaching 2 minus. As we move towards 2, you read the functional value from the table, it's 4. And you also read the value from the graph. The functional values reach all the way up to 4. Now similarly, let's see the second column of the table where the x values are decreasing. You start from 3, you go all the way up down until 2. And then you read the corresponding functional values. Start from 8, it goes down all the way up to 4. So you start from 3 and you move towards 2. So this is moving towards 2 from the right. So you call it as a right hand limit. X approaching 2 from the right. So it's 2 plus. Again, plus 6, nothing to do with the addition or like summing up, but it's something to do with the direction. Plus moving towards a number from the right. Negative sign moving towards a number from the left. And we have a name for these. Moving from the left is the left hand limit. Moving from the right is the right hand limit. Now we say that the limit x approaching to minus f of x and the limit x approaching to plus f of x, they both are equal and they are equal to 4. We are able to see that from the graph too. You're seeing that the graph, the value approaches 4. Because the left hand limit and the right hand limits are the same, you say that the limit exists. In order to say that the limit exists, the left hand limit and the right hand limit should be equal. So that's what is explained here in words. Now let's do this example. Explain what it means to say that the limit x approaching 1 minus f of x is 3 and limit x approaching 1 plus f of x is 7. So let's do this. The left hand limit x approaching 1 minus f of x is 3 and the right hand limit x approaching 1 plus f of x is 7. When x is approaching 1 from the left and 1 from the right, you see that the limit values are not the same. So the question is asking you, is this situation possible that the limit exists? Your answer would be no. The limit x approaching 1 f of x does not exist. So we can also say this as D and E. D for does and for not, E for exist, does not exist. In the second example, you're given a graph and you're asked to answer the following questions. Limit x approaching 0 f of x. So here you have x approaching 0 from the left and from the right. You want to read the functional value from the left and from the right. The value is the same. The limit value approaches 4. So your answer is 4. Though we write it as a 4, you have to understand that you have a hidden definition here, that you have two parts of the definition. X is approaching 0 from the left, f of x is 4. X is approaching 0 from the right, 0 plus f of x is 4. Hence, you say that the limit of the function is 4. Now, the next one, x is approaching 3 from the left. X is approaching 3 from the left. So, you see the left-hand side and you read the graph carefully. You see the functional value is approaching 4. So, though you have an open circle, which means that point is not included, but it's going towards 4. So you're going to say that this value is 4. Next, limit x approaching 3 plus f of x. So moving towards 3 from the right. And you see the value of the limit is approaching 2. So you're going to write this as 2. Next, x approaching 3 f of x, which means you read the left-hand limit and the right-hand limit. You see that they are not the same. So your answer is does not exist, because left-hand limit, right-hand limit are not the same. Now f at 3 is 3. This is just reading a graph. It's nothing to do with the limit. Exactly at 3 you have 3 points, but you have 2 open circles. Those points are not included. So this is your answer, which is 3. Now we have a note. Limit x approaching a f of x is L if and only if the left-hand limit x approaching a from the left, a minus, and the right-hand limit x approaching a from the right, a plus, they both are equal. Then you can say the limit of the function is L. Or else you say that the limit does not exist. So let's do this. You are asked to sketch this piecewise function in this problem, and you're also asked to find the value of the constant a. So first, let's try to sketch this graph. Draw x-axis, y-axis, and a few points on the x and y-axis. For x less than -1, you see a straight line 4 plus x. Exactly at x equal to 0, you have the value of the function to be 4, which is the y-intercept. And when y is 0, you see that x takes -4, which means it's a line passing through -4 with a height 4 but not crossing -1. And you can also mark an open circle because -1 is not included. So this is the line y equal to 4 plus x, or f of x equal to 4 plus x. Now for -1 and 1, you have y equal to x squared, which means it's a parabola. And when you plug in 1, you see the functional value is 1. So you want to draw a parabola with a height 1 passing through the origin. The left hand side you have a less than or equal to, so you're good to mark and close the circle. The right hand side is just less than, so you want to do an open circle. Then you have 2 minus x is the line for all x values which is greater than or equal to 1. So it's a straight line with a negative slope. When x is 0, you see that the y-intercept is 2. And when y is 0, you see the x value is 2, which means it passes through 2, 0. The height is 2 and it passes through 2, 0. So you want to draw a line. This is your f of x equal to 2 minus x with a height 2. This is your f of x equal to x square curve. Whenever you have a less than or equal to in the piecewise function, it's always a closed dot. The point is included. When you have just less than, make sure you have an open circle. The point is not included. So now let's get back to the question. Question is asking you to find a for which the limit exists. So let's read the points very carefully. Let's first choose -1 as a point of discussion. So we're going to discuss the limit of x approaching -1 from the left and the limit of the function when x is approaching -1 from the right. I'm going to write f of x for both. Now read the graph carefully. When x is approaching -1 from the left, the value of the function approaches 4. So I'm going to write this as 4. Whereas when x approaches -1 from the right, the value of the function approaches 1. So you see that these values are not equal, which means a cannot be -1. So let's try to discuss the limit for x approaching 1 minus approaching 1 from the left, x approaching 1 plus approaching 1 from the right. Now let's again read the graph carefully. Approaching 1 from the left, the value of the function is 1. Approaching 1 from the right, the value of the function is 1 again. So you see that the left hand limit and the right hand limit are the same. So limit x approaching 1 f of x equal to 1. I want you to check this value here, this calculation here. When x is greater than or equal to 1, the functional definition is 2 minus x. So say I plug in x equal to 1. The value of the function is 2 minus 1, which is 1. And say anything greater than 1, say 2, value of the function will be 2 minus 2, which is 0. Hence the line passes through 2, 0. So I want you to check this carefully and change this a little bit. This should be a line which passes through this open circle here. So there is also a closed circle. I'm going to mark this with a closed circle as well. And then it passes through 2, 0. Now you see the left hand limit of 1 and the right hand limit also approaches 1. And hence we have 1 and 1, the left hand limit and the right hand limit. So the question is asking you what should be the possible value of a. So from this one you can say that a equal to 1, because you compare this to the definition limit x approaching a f of x equal to L, and then you will be able to figure out the value of a. In the next example, you want to sketch a graph of the function which satisfies all these definitions. You have two values given. F at 0 is -1. So at 0, -1, you're going to make it as a dark circle here. And f at 3 is 1. At 3 it's 1. Again, you want to make a dark circle here. So these are the points which are included in the graph, and it should be a closed circle. Then you have x approaching 0, the limit is 1. So towards 0, when you draw a curve, the curve should pass through 1. So you can draw a curve like this. And then when x is approaching 3 from the left, the value of the function is -2. So say here is 3, and the value of the function is -2. And then when x is approaching 3 from the right, the value of the function should be 2. So I want you to draw a nice smooth curve which shows that the value of the function is 2, which is an open circle. But again, there's one more curve coming from the right here, which shows that the value of the function is 2 here. So read the graph carefully, which matches the definition as well as the values. So when we say an open circle, you have to understand this is the point which the limit value is approaching. And when we see a closed circle, this is an exact point on the graph. In the next example, we use the table of the values to estimate the value of the limit. So limit x approaching 0 minus 0 from the left, sin x divided by sin 2x. So this is limit x approaching 0 minus sin of -0.001 divided by sin of 2 times -0.001. So simplify, you get 0.5. So when x is approaching 0 minus, we don't plug in 0 itself for the x value. But what you do is on the number line, you want to mark that this is 0 minus and this is 0 plus. For a 0 minus, you're allowed to choose a value of x which is approaching 0 from the left, -0.001, approaching 0 from the right, 0.001. And then similarly, you want to try one more calculation for x approaching 0 plus. You have sin x divided by sin 2x, and the limiting value is 0.5. Now use the graph of the function to state the value of each limit. When x is approaching 0 minus, the functional value will be 3. 0 plus, the functional value will be 0. And when x is approaching 0, you see the left hand limit, right hand limit are not equal, which means this limit does not exist. We'll end this section here.